Hi class. So far, what we learn is we have a function and we trying to find the rate or like the velocity. So now, how about we have the rate? So for example, a biologist who knows the rate at which the bacteria population is increasing might want to deduce what the size of the population would be at some point in the future. So we're gonna have to so it's the reverse. So we have the derivative and we want to go back and find the original function. So that's what we call the antiderivative. So you see right here the definition. A function f, usually we use the capital F, is called the antiderivative of f on an interval I if f prime is f of x for all x. And then we have the theorem right here. So the theorem right here, we need to take care of c, which is the constant, and I will show you why. So for example, let's just take a look at take a look at the example first. Okay, so for example, um, before I move on to those examples, I want to give you the power function first. So let's take a look at f of x equals to x squared. So f of x is going to be 1/3 x cubed. Now think about this. When you take the derivative, you get x squared, which is f of x. But let's consider, I shouldn't use f. How about g? What if I got 1/3 x cubed plus 2? When I do the derivative, I still I still ended up with x squared, which is also f of x. That's why we have the theorem above. That's why we have this theorem. So you have to consider the constant, because when you take the derivative of a constant, it disappears. Okay, let's take a look at that example. So the example, what we have right here, we want to find the most general antiderivative of each of the following function. So sine. When you take the derivative of cosine, you're gonna end up with negative sine, right? So the antiderivative of this one is gonna be negative cosine of x, because when you take negative cosine of x, you're going to end up with a negative sign, which is positive sign. Don't forget, we have to add the c there because we're looking for the most general one. Okay, now what do we have for 1 over x? So the 1 over x, what is the function that when you take the derivative, you ended up with 1 over x? Hopefully you still remember. Is the ln function. And then make sure you put c there. And then of course I have to include the absolute values. All right, moving on to the x to the n power. You see, this is what we have for the power function for the antiderivative. You're gonna take n, you're gonna add 1 to n, right? And then you're gonna divide n plus 1 right there, plus c. So that's going to be the general one, the formula for the power function. And I include a table right here for you to see. You should memorize. It helps. It helps tremendously if you can memorize the anti-differentiation formulas. Okay, for the function, the trig function, at least try to memorize the sine and cosine. Okay, So that's a table right there. Oh, I want to point out this one. You're going to see this one a lot, the arctangent, that one. Okay, moving on to example 2. So what you see right here, we want to get the antiderivative of this one. So how do we do it? First of all, you should definitely simplify first. For sine of x, I should definitely simplify the power. So I get 2x to the 5th power minus, you see right here what we have is negative x to the 1/2. Now 1/2 minus 1, which is 1/2 minus 2 over 2, which is a negative 1/2. So that's what I have. Okay. All right. Now we are ready to take the antiderivative. So what do I have for the antiderivative here? I got 4. So how do I get go back? You can always go back to the function, the antiderivative formula right here. So the function is sine. So what would be the antiderivative? That would be negative cosine. So negative cosine. Because think about it, cosine, when you take the derivative, you ended up with negative sign. Okay, so what I have right here is going to be 2x to the 6th power over 6. And then for the power here, same thing. We're going to get x negative 1/2 plus 1, that's going to be 1/2, divide by 1/2, which is 2. Okay, so you can do some simplify. By the way, if you want to check your work, you can always go back and take the derivative. So if I want to take the derivative, I'm sorry, I should change this. This is not the equal right there, so I should put g here. Okay, now let's try to take the derivative. Cosine derivative is negative sign, so it's going to be positive sign. Okay, taking derivative, you bring 6 to the front, you minus 1 to the power. Taking derivative, you take 1/2 to the front, you minus the power. Okay, so what we have is 4 sine of x plus 2x to the 5th power minus 1 over square root of x, which is the original that we have. All right, moving on to example 3. So we want to find the antiderivative, find f if f prime is e to the x power plus 20. And then you see right here we have to the negative first power. So if I want to rewrite, it would be like this. Okay, so that would be the f prime. And keep in mind, f of 0 is negative 2. So hopefully you recognize that this one right here is the derivative of arctangent. Okay, so taking the antiderivative, we get e to the x power plus 20 arctangent plus c. Okay, now to determine c, we're going to use the fact that f of 0 is negative 2. So we plug it in. F of 0 is going to be e to the 0 power plus 20 arctangent of 0 plus c equals f of 0 is negative 2. So I'm going to put negative 2 in. But e to the 0 is just 1. Arctangent of 0 is just 0. So that's 0 plus c equals negative 2. So c has to be negative 3. So we're going to go back and rewrite our function. F of x is going to be e to the x power plus 20 arctangent minus 3. So we include the c in there. All right, moving on to example 4. So what I have is the second derivative. So we're going to have to find the first derivative and then so on. Okay, so first derivative, antiderivative, f prime of x is going to be, so 12x, and then you add 1 to it, add 1, divide by the same number, plus 6, add 1, divide by the same number, minus for the constant, you just include x. And don't forget the c. All right, I'm going to simplify it. So I get 4x cubed plus 3x squared minus 4x plus c. I'm going to go ahead and do the second derivative. So the antiderivative of f prime is going to be f of x. So we have 4 x to the 4th power over 4 plus 3 x cubed over the same power minus 4x squared divided by 2 plus c times x plus, now we have a new constant, plus d. Now I'm going to use the fact that f of 0 equals 4. So f of 0, what do? We plug it in, right? So that's just x to the 4th. So it's going to be 0 to the 4th plus 0 cubed minus 20 I'm sorry, minus 2 times 0 squared plus c times 0 plus d, and that's everything is gonna add up equals to 4. Okay, so we have 0, 0, 0, 0, 0, so d has to be 4. Now, I'm gonna go back and use this one. Okay, so we're gonna have to evaluate f1. Okay. Oh, so we use this one. I'm sorry, we use this one. Okay, so f of 1 is going to be 1 to the 4th power plus 1 cubed minus 2 times 1 squared plus c And then d we have is 4. 4. And that is gonna be 1. Okay, so I got it from here. Hopefully you recognize that. So that's 1. And then we just use it to solve for c. So c is -3. So now we're ready to write the whole thing. So we have x to the 4th plus x cubed minus 2x squared. C is -3. X plus 4. So that's gonna be our function. Okay, let's take a look at this application problems right here. So what's given to us? What's given is the speed. The speed. Okay, and then we have from the edge of the cliff for 32 feet above the ground. They're asking you to find the height above the ground t second later. When does this reach its max, and when does it hit the ground? So what do we know? We know that at time t, the distance above the, okay, let me write down at time t. The distance above the ground, s of t. Remember, when we use distance, we use the s function. So at time t, the distance above the ground, s of t, and the ball is vertical like this, right? So v of t, the velocity is decreasing. Okay. Now, if the velocity is decreasing, the acceleration is going to be negative. Okay. So if we have an object near the surface of the earth, of the earth, an object near the surface of the earth is subject to gravitational force that produce a downward acceleration. We're going to call it g. So for motion close to the ground, we assume that g is constant. And hopefully you still remember this. So we have 32 feet per s square. Okay, so what do we have now? So don't forget, earlier we mentioned that the acceleration is a negative number. Now, don't forget acceleration is the derivative of the velocity, which is dv over dt. Okay, so we're going to take the entire derivative to find v of t, which is -32t plus a constant. Now, we're going to use the fact that v of 0 is 48. Okay, right here. So you see right here, a ball is thrown upward with a speed of 48. So we know that v of 0 is 48. Let's plug it in. V of 0 is going to be negative 32 times 0 plus c is going to be 48. Therefore, c has to be 48. So now I'm ready to write my velocity function, which is negative 32t plus 48. Now, the maximum height is reached. When do we reach the maximum height? That's when v of t, the velocity, is going to be 0. So I'm just going to plug it in and solve for it. Okay, so if I solving, I get negative 48 here, negative 32t, so t has to be 1.5 second. Okay. Now we're going to go back and find the position function, which is s of t. So s of t is going to be negative 32t squared over 2 plus 48t plus d. I'm going to simplify it so we get negative 16t squared plus 48t plus d. Now we're going to use the fact that s of 0 is 432. Therefore, when you plug it in, d is going to be 432. Now, the ball hits the ground. What do we mean by that? When it hits the ground, that means s of t is going to be 0. And we are looking for the time. So I'm going to take the function and set it equal to 0. Negative 16t squared plus 48t plus 432. Set it equal to 0 because it hits the ground. And then from there, we solve for t. So we have t squared minus 3t minus 27 equal to 0. So I'm going to just go ahead and use the quadratic formula. So t is going to be 3 plus and minus square root of b squared minus 4 negative 27, okay, over 2 times 1. Okay, if I simplify it, I'm going to end up with 3 plus and minus 3 square root of 13 over 2. Don't forget we have to eliminate the negative number, so t cannot be negative. So I use a calculator and I ended up with 6.9 seconds. That's how long it takes for the balls to hit the ground.